Hey, hi everyone. In this session, we are going to discuss about LVM, which is Logical Volume Manager, and LVM is a partition type in Linux. So, whenever we are storing the data, usually that goes into the partitions. There are different partitions type which we can create in Linux, sort of which the LVM is a very popular, partition type, and we need to understand like what is the procedure to create the LVM partition, how to uh, handle the data, how to mount the partitions, how to remove the partition, or maybe how to extend the existing partition when we are talking about the LVM. So let's go and quickly understand this. So LVM is a logical volume manager, is a disk management and storage system that allow for flexible and dynamic allocation of storage space on a Linux system. So whenever we are talking about any operating system, usually it require a partitioning even for installation, because to store the data you need some physical space, and that space comes from the partitioning. So take an example. If you have a hard disk, okay, and this hard disk is usually so let me just select this and okay. So the hard disk is always having for example, in this case this hard disk is around 80 GB of space, okay. And when we are creating a partition, so the definition of partition is very simple: the act of dividing hard drive. This is you can consider this as a hard drive. So the act of dividing hard drive into multiple logical storage unit is called as a partition. So suppose if I'm dividing this into different spaces, for example, this one I have created as a 20 GB, this one I'm creating as a 20 GB, and this one I'm creating as a 20 GB. So still we have a 20 GB of space left, right, which is a free space we can consider, and these three partitions are created into this particular hard drive. So in Linux, the initially, okay, whenever the system performs the installation, it requires three type of partitions or three partitions. That is slash, which is the root partition. This is the main partition where entire file system is installed. Then we have slash boot partition, and there is one more partition called swap. So swap is a virtual memory, okay, which is used when your physical memory is not sufficient. So whenever this Linux installation happens, these three partitions are by default created, okay. So slash, slash boot, and swap. So here slash boot is always referred to as a primary partition in Linux, okay. So let's understand like how it works. So primary partition is required to install the bootloader program or bootloader related files, right? And this particular partition in Linux by default creates as a LVM, okay. So when we will learn like how to create LVM, and what is the procedure for it, and we are going to use it for storing the data. So similarly, during the installation it automatically happened, and slash is created as a LVM partition, slash boot is created as a primary partition, which is a standard partition type, and swap partition is also created as a LVM partition, okay. So this is also created as a LVM partition. But what is the LVM and why we are using LVM, that we will understand now. So we now have a fair understanding of in for any operating system, if you are doing the installation or storing the data, it requires the partitions, and partition is nothing but the act of dividing this hard drive into multiple logical storage unit. So based on the space available, you can create a partition structure. So in a standard Linux you know production environment, when we are creating a partition, it's mostly we are creating different sets of partition. For example, so I'll just clean up these. All right. So usually when we are creating a partition, there are three types of partition in Linux. So that is, one is the standard partition. So standard partition. These standard partitions are again subdivided into three category, that is primary. Second one is extended. And third one is a logical partition. We will also understand like what is the difference between standard partition and LVM partition. So the standard partition is having three categories like primary partition, extended partition and logical partition. The other one is LVM. So LVM is independent partition type where we are creating logical volumes, okay, LVs. And these LVMs are having the feature that you can resize these partitions on the fly. You can resize that we cannot do in this particular partition type. So if you have created a partition of, for example, here if I created partition of 100 GB and it is mapped to, for example, slash data, and if it is 100% utilized for, then you cannot extend this particular partition. So the next write operation will not happen and it will impact your application or maybe whatever the operation is going on. So in standard partition usually this is the risk, and for that reason there is a mechanism called, or the different type of partition in operating system terminology, that LVM, which we can create. So dynamically we can handle the sizing of this particular partition. So let's understand this. So there are three important components of LVM. One is physical volume. So whenever we wanted to create a LVM partition, usually we would require a physical volume which can be created from hard drive. Means if you are attaching a disk of for example 100 GB, then you can create 100 GB PV from that particular hard drive. The second option is if you have a partition within your hard drive, that partition can also be act as a physical volume. And the third is RAID array. So RAID is one of the partition type which is widely used in hardware level. So RAID stands for redundant array of independent disk, where multiple physical hard drives are combined and they create the logical volume. So if you wanted to understand the RAID, then usually it will be like this. So let me quickly go. Okay. So let's understand how RAID works basically. So if you have a server, okay, and there are multiple hard disks to this particular server attached. So 1, 2, 3, 4. This particular hard disk group of hard disks is called as array. Okay. So now whenever there is a RAID utility, actually there is a RAID utility available in all the hardware vendors, whatever they provide the servers like IBM or HP or Dell. So they people have provided the RAID utility by which you can create the RAID partition. Now how it works? So whenever you are creating a RAID partition, it actually combines these 4 hard drive. Take an example, each hard drive size is 100 GB. So into 4 I have 400 GB of storage, and RAID performs based on the RAID levels. Okay, RAID performs based on the RAID levels. So RAID level 0, RAID level 1, RAID level 5, okay, like that there are RAID levels. Okay, so whenever we are creating the RAID partitions at the hardware level, usually this type of RAID levels can be selected. Now what is the meaning of it? Okay, let's understand. So RAID level 0 is used for striping. So whenever there are two disks, okay, minimum two disks required for this, so data will go into both the disk, and this is the fastest read level when you are creating the RAID partition. The RAID level 1 is for the mirroring, so two minimum disks are required. So when you are storing the data in one disk, okay, then automatically the mirror is created into another disk. So RAID level 1 works for that. Then again RAID level 5. So when we are creating the RAID level 5 partition, it actually required minimum 3 hard disks. Okay, so in RAID level 5 usually data is going to all three hard disks, and with one of the concept called parity bit, which will perform the errors in the particular hard disk, and if one hard disk goes down, it will automatically use the standby disk, okay, and rebuild this particular RAID array. So this way you can you know protect the data at the hardware level. Now when the physical level RAID configuration is done, these three hard disk partitions is creating one logical volume, or we can refer the partition which is coming from the RAID is virtual disk. Okay, so it creates the virtual disk from this physical partition, and this virtual disk can be of size, for example, 300 GB. So now my physical server having the 4 hard disk attached of 100 GB of size, I created a RAID partition which is redundant array of independent disks. Means these disks are not depends on anyone, each other. So if one disk goes down, or it is crashed, for example, or it becomes a faulty, then the spare disk you can keep as a spare disk, and that can takes part of this particular array. This way data is always traveling between multiple disks, and it is safe. And when you create this RAID partition, actually you are getting the virtual disk of size, for example, 300 GB, and this V disk, virtual disk, is visible at OS level, and we are creating operating system level partitions from here. So here now we will create the LVM partition. So this was the the hierarchy, or this is the workflow when you are creating the partitions. Nowadays we have a cloud system, so everything is virtually created, but that is coming from this particular structure only. Okay, there are physical servers. These servers are configured with the RAID partition type, and there are virtual disks created out of this RAID partitions, and these virtual disks are now available as a disk to the OS, and from that particular disk the LVM kind of partitions are created. So we understood there are three types of partition, or these terminologies with respect to partition, where we are usually operating with. So one is standard partition, primary, extended, logical. The next is LVM, and the third one is RAID partition type. Okay, so let me just clean up this. Sorry. All right, so when we are creating the LVMs, usually we are seeing the disk which is available at OS level. So let's figure it out that. So here if we go and if you run the fdisk, so this is my server, and if I execute fdisk-l, then I can see there is a disk attached, that is /dev/sda, which is of 20 GB size. Okay, so during the VM creation, virtual machine creation, we have attached the 20 GB size to this particular VM. So if you wanted to see that also you can see. So this is the application server, for example, and during the installation we have attached 20 GB hard disk. So if you go to the setting, you can see the storage, and in the storage you can see the controller SATA app server.vdi, which is virtual disk of size 20 GB. Okay, so this disk is visible at OS level. Okay, so now within this particular hard disk there are two partitions are created, SDA1 and SDA2. Now the naming convention says that this is SATA disk, and A stands for this is the first disk attached to this server. If you are attaching second disk, then it will name as a SDB. Okay, that we will see. So in this first hard disk attached to this server, SDA1 and SDA2, two partitions are created, out of which the first partition is a standard Linux partition, which is a primary partition used for the booting of operating system or bootloader related partitioning. Okay, the size of this partition is 1 GB. The second partition is created inside this hard disk, and that partition is used for or labeled as a LVM partition. Okay, so when we are creating the LVM partition, we required a physical volume, and physical volume can be created from the partition or complete hard drive. Okay, that is what the first point says. So physical volume, these are the actual storage devices, that is hard drives, partitions or RAID arrays that LVM uses as its building blocks. And from this physical volume we can create the volume groups. So now let's understand that. And if you wanted to check like how many physical volumes are present in your system, you can execute the command pvs, a simple command, and you can see that it is listed that /dev/sda2 is a physical volume available in the system. So that is what we can go and verify also. Okay, now in the LVM, when we are creating the PVs, those PVs can be part of a volume group. So let's understand. Volume groups combines one or more physical volumes into a pool of storage. It's at this level that logical volumes are created. So when you are combining one or more physical volumes into volume group, the total size of the volume group increases based on the number of physical volumes available in it. So in this scenario, if I go and check on the system by using VGS command how many volume groups are there, so you can see that the VG R1 is available in the system, and one physical volume is also part of it, and the size of that volume group is 19 GB. So as we can see in the previous output, that SDA2 physical volume is basically part of the volume group R1. Okay, so that is where this 19 GB of partition is acting as a physical volume, and then it is part of the volume group R1. Okay, then inside the volume group you create the LVs. So logical volumes are equivalent to a partitions in a traditional disk management setup. They are created within volume groups and serve as the mount points for the file system. So it is very simple to understand, like what is the mount point. This is the new word maybe you are encountered to. So mount point is nothing but the file system for accessing the partition. So whenever you are creating the partition, it requires some sort of label, right, where you can store the data, where you can access this particular partition. So in this scenario, if I go and check how many LVMs are created, I can use the LVS command, and you can see that there are two LVs created. One is root, which is main/partition, and the other one is swap partition. So I just discussed that there are three partitions are required to install the Linux operating system, that is /boot, / and swap. So here we can see that /root / the main root partition is created as a LVM. Swap is also created as LVM, and the /boot partition, which we discussed, as created standard partition. Okay, so we can see two LVMs are there and 17 GB of size for one first LVM, and swap is 2 GB. Now how you will check that what are the mount points? So df-h, this command shows the mounted file system, because we are referring these partitions as a file system, and you can see that the R1 or RL, it may be, the name you can define to, these groups, anything which is appropriate with respect to, for example, if it is for application, then vg underscore app or something like that, that we are going to create. So rl for rel, maybe hyphen root is the lvm. So 17 GB of size, and this particular lvm partition is mounted on slash. Whatever data or whatever, file folders which we are handling or maybe operating with are coming from the slash. So this is the main root directory. Like in Windows we have C drive, similarly in Linux we have a slash, which is, the main file system. So this file system or this partition is LVM partition. And how we understood? Because the root and RL is part of the LVM strategy. So I can see that the volume group is RL and root is the LVM partition, which is LV. So this way we got this particular, hierarchy. Now how it created? During the installation, system automatically creates this structure, because for installation it requires 3 partition. So when we are talking about this 3 partition, usually, again I'm going back and so first partition is slash, the second partition we are referring as a boot partition, and third partition we are referring at as a swap partition. Okay. So these 3 partitions are automatically created during the OS installation. Slash and swap, these partitions are LVM type of partition, and slash boot is a standard primary partition. So this way these 3 partitions are automatically created during the installation. Okay. Now we need to understand how to create the LVMs, what are the requirements. So as we understood, like to create a LVM it requires physical volumes that can be created from the additional disk we can attach, or maybe the partitions which we can create into the disk. The next is, once your physical volumes are created, you can attach these physical volumes or add these physical volumes to the volume group. Okay. And then volume group can be combined, one or more physical volumes, and after that you can create a logical volume into the from that particular volume group, and that way you can create a LVM partition. So we'll understand that. If structure wise, if you want to understand, we can see like this. Okay. So let's take example. This is the hard disk. You have 2 options. Either entire disk can become PV, or you can create a partition in it and make as a PV. So for example, if it is 80 GB of hard disk, the physical volume size will become 80 GB. Okay. Now here if you created the physical volume of size 20 GB for example, then this PV will become 20 GB ka PV. It's very simple. So still you have around 60 GB of space left in the hard disk. So this is the free space. This is absolutely free space. Now take example, I have a 80 GB of hard disk, out of which I have created a 20 GB partition, which is a standard primary partition, which is standard primary partition. And then I converted or created as a PV. So to create the PV, the command is PV create. It's very simple. Okay, PV create and the name of that particular partition. After that, you attach this PV to the volume group VG. So 20 GB is now attached to the volume group, and you can name it as any name, like VG underscore app, or maybe VG underscore DB, okay, which will reflect for the database to store the database related files, right? So you can create a volume group from the PV. Now this volume group size will also become a 20 GB. So I have 20 GB in the volume group. From this volume group, I can create LV, that is logical volume. Now it depends like what is the size requirement for your partition. LVs are nothing but a partitions, right, which we are going to use for with certain mount points. Okay, so let's take example. I have one requirement for installation of Tomcat. Okay, so I am creating a LVM called LV underscore Tomcat. And the second LVM which I am going to create just to store the data. So LV underscore data, I have just given a name. Out of 20 GB, I created this LVM with 5 GB and this next LVM with 5 GB. So we are understanding the concept actually, how it works and what are the benefits of it. So out of 20 GB of volume group size, I created two LVs, that is 5 GB, 5 GB. So still I have a 10 GB of size left in the volume group. Okay, so I'm using this. Now the data is coming into these partitions, okay, because when we create these LVs, we are actually mounting these LVs as a, or assigning the mount point, for example /app/tomcat. Alright, so now whatever the data I'm storing under /app/tomcat is actually going into this LV underscore tomcat partition, which is of 5 GB of size. Okay, so this way we are using the partitions in operating system, or whatever the applications are storing the data, it actually goes like this. Now if my 5 GB space is 100% utilized, it is full, right, all the data, there is no space left on this particular device. Okay, and in that scenario I have a 10 GB of space still available in volume group. What I can do, I can extend this particular LVM with available space. So what I can do, I can extend the LVM. So this is the best feature, and that too online without impacting the data. So in this scenario, I can extend this LVM from 5 GB to another plus 5 GB, and then I will have the space available, or to store the data. Maybe that time we can handle the situation where application is continuously storing the data into it, and you don't have space, but having the LVMs, right, you can extend or resize the partitions on the fly without losing the data or without impacting any data. That is the feature, and that is why in industry, on the operating systems, these partitions are created. So now take example, even if you are using the cloud or virtualized environment, the terminology is same. Okay, this type of virtual partitions are created, and those partitions can be extended or resized online. Okay, so this is how the LVM works. Okay, so what is the drawback of standard partition? If I have a standard partition, for example, here I created a standard partition of, for example, 20 GB, and I have mounted that as a /data. If this 100% full, I cannot extend this partition. There is no way of it, because this is the physical drive, and inside this drive we have created this partition. So I cannot go and increase this space like this. Okay, so that is why standard partitions are having the limitations, and due to which we always prefer, and in the production environment or in any environment which you are working in industry, mostly LVM partitions are used. And now we need to understand how to create physical volume from this hard drive, how to create a volume groups from the physical volumes, and then how to create LVMs, how to mount it, and then how, if the data is 100% utilized, then how we can extend those LVMs. Okay, now take example, I don't have space left in volume group as well. Okay, the other 10 GB is completely utilized and given to the LVMs. What will happen? I can create one more PV, like for 20 plus 20, 40 gone. I have 40 GB still left. What I can do? I can create one more PV and I can extend this volume group. Now my volume group become 60 GB. Okay, so even if 20 GB is utilized from this volume group, I have next 60 GB available that can be used to extend these LVMs. So ultimately the end partitions are not impacting because of the storage, like challenges, the space challenges. Even I can attach a new hard disk of 100 GB, and entire hard disk can be created as a PV, and that PV can be added to the volume group. So again I can increase the space of this volume group based on multiple physical volumes, and that is where I will have opportunity to extend the logical volumes on the fly with any size requirement. So this is how we have understood, and that is where it is said that the volume groups combines one or more physical volumes into a pool of storage, and from there we are creating the LVs. So in this scenario also, let's understand from the OS point of view. In this scenario also, if I have a slash partition which is 13% used right now, and if I get alert on 80 or 85% that there is a warning alert, for example the 85% of slash is used, what I can do, I can provision a new physical volume and I can extend the volume group and then I can increase it. So let's practically see that also how it works. So as a concept we understood like how the LVM works or what are the different types of partitions in Linux. In the next session we are going to create a LVM. You can see that the assignment one. So we will create the LVM, we will attach the hard drive additional 20 GB of disk to this particular instance or VM, and we will see how to create the volumes and how to map it. So see you in the next session guys, and just walk through the concept of LVM, logical volume management, and understand how the terminology works for this partitioning. All right, see you.